we are going to do a titration lab, and a titration is really a neutralization where we measure amounts. So HCl, or hydrochloric acid, is going to be our acid, and sodium hydroxide is going to be our base. And when we combine them together, they're going to neutralize to form water, and then a salt. In this case, the salt will be sodium chloride. We're trying to figure out the molarity of this HCl, and what's going to happen is we're going to use 10 milliliters of it, so we know the volume of it. We know there's just one hydrogen in it, so the Na will be 1. We're going to use a standard base, which is in the burette. That is going to be 0.100 molar, so that'll be the molarity of the base. The volume of the base is going to be measured, so we don't know what that is, but we're going to measure amount, just the amount it needs to neutralize the acid, and then the NB is going to be 1 from right here. So ultimately, we're going to get to know 5 of these things, and then we can solve for the 6th thing right there. So I'm going to go right to that, and I'm going to look at the procedure here. There are like 12 steps there. The first couple steps, it says they're done already. So I've taken this burette and I've actually rinsed it out with a base. I don't want to rinse it out with water and put things in there, because if I leave a little extra drops of water, that's going to dilute the base. I want to have exactly 0.100 molar NaOH in there. The next thing, and so I rinsed that out, and then I filled it. I just want to make sure I have enough to do my titration, and I do. Okay, sometimes I will burp that burette, okay, to get any air bubbles out of there. Okay, it looks like it's well burped right there. And let's see, I'm going to take a measurement of this, and I'm going to read from the bottom of the meniscus. And remember how this goes with the burette? It goes from 0 to 50. It doesn't matter, you're not going to really know the exact amount in there, but you're just taking a difference from the initial reading and the final reading and taking the difference. There's a lot smaller increments on here. We can read it quite precisely because it goes to the nearest tenth. I'm going to call this 16.50. So this will be 16.50. I should write that down, but we're going to remember that. Okay, so I'm going to record that. We don't have to worry about an unknown number in number 6. It says rinse a grad cylinder with, this is our dump bucket, and it says rinse it with distilled water. Okay, so I'm going to do that. I'm going to put a little bit of this in the dump bucket. Now, do I have to dry it out? No. We're trying to keep track of H plus and OH minus and getting the same amount of each. If there's extra waters in here, it's not going to affect things. So that little water residue is going to be fine. If I had more water residue, it's fine because there's equal amounts of H plus and OH minus in this distilled water. The next thing I'm going to do is, it says carefully measure out 10 milliliters of my HCl. So I'm going to grab this right here. I have this right here, and what I'm going to do is actually put some in this flask, and I'm going to dump it out. And the reason is I'm rinsing out this flask, so it's only the unknown concentration of the acid. I'm going to put it in that dump bucket right there. And then what I'm going to do is I'm going to measure. So I'm going to put in about 10 milliliters here, and I'm going to get pretty close, and I am going to take this little pipette bulb, which has also been rinsed with the acid, and I'm going to add just enough to get that right on the 10. Okay, so that looks pretty good. Okay, a more accurate way to do that would be a pipette like this, and I could draw it up and get that, but this should be pretty close right here. We would still be pretty precise with that. Okay, so I'm going to take this. I have 10 milliliters of this acid here of unknown concentration. I'm going to dump it in here. Now what happens is I still have a little bit of acid left in there, and I want to get all those extra H pluses out. So I'm going to put a little bit of extra water in there, about half full, and roll that in there. The extra water won't hurt, but it'll help me get all the H pluses out so that this matchup of H plus and OH minus is going to be the same. Okay, so I have this container, I'll swirl it around, and then the next thing it says, add your indicator. If you don't add the indicator, it won't change colors. We're going to go till it turns a pink color that persists for about 15 seconds. 3 or 4 drops, I'll put those in there, and then I'm going to start dropping the base. All right, and I'm just going to go double check. It looks like it's still at 16.5. Nothing has changed since we started this, and I'm going to add this in here. I don't know if you want to come closer and take a look, or can you see that? And I'll see this turning pink right on the spot, but if I swirl it, it gets clear. Now I've kind of rehearsed this so I know about when it's going to change. If you're doing an unknown you don't have anything about, you might do a titration to find the range, what's close, and then you might follow up with a couple titrations once you figure that out. Since I've kind of rehearsed this, I have an idea when this is going to change and do that. So notice it turns pink where there's base, because it's local, where that base lands, it's going to be more pink. I'm living a little bit dangerously. I'll turn that. You don't want to overshoot your endpoint right here. Okay, I'm going to keep going a little bit. I'll go a little bit more. A little bit more. I'm getting close. Now when I get close, I like to take readings, and sometimes I'll do a quick flick with this thing. We're about 25 milliliters. Okay, we're getting real close, getting close to 26 milliliters. And sometimes I'll look at this and say, okay, put a little bit in, and it's at, let's see, 25.9. Okay, then if I put a little bit more in, and the next time it's at 26.1, let's say I overshot that, well, the most I could be off by is 26.1 minus 25.9. It'd be a couple tenths of a milliliter. This is getting really, really close, but I'm going to try to get this right on. I'm looking at this. It's like 26.3, and I want a pink endpoint that's going to stay for about 15 seconds. It looks like we're really close. I'm going to go maybe one more drop here. Okay, and notice that one drop made it, whoops, sorry, I should keep this down here. That pink color, it's persisting. We're right about on the top of it. If I'm off by a drop, it's not going to be a big deal because you're just trying to get close to that volume to do your measurement. Okay, we'll put one more drop in there. Okay, and that's getting to be a pink color that looks like it's going to stick around for a while. And I'm going to take this final reading. It looks like it's about 26.4, and that what I would do is subtract my initial reading from my final reading, and that would be my volume of my base. Just something about a pH curve that you have, and notice the pH doesn't change much, and then near the end point, like maybe 4 to 10, it's like 2 drops is going to drastically change that. If you're off by 2 drops out of 10 or 20 milliliters, it's not going to have a big effect on your calculation of results. However, if your goal is to drink this because it was a neutral substance, that would be a different story. But our goal is not that right here. Watch what happens when I add just a little bit more. One quick flick, it's really, really dark. I added maybe a fraction of a mil, maybe a tenth or 2 extra, and I move right in here all the way over to here on this titration curve, and you get that really dark pink color. Okay, so for your assignment, you have some information about reading the Barrett. You come over here and take a look, and then you have a couple different Barrett readings. You can subtract the final one minus the initial one to figure out your volume. Pay attention to sig figs when you do that. Do your calculation to figure out the molarity of the acid in this case. Follow the same conditions for the milliliters of HCl and the molarity of the NaOH that we have in our procedure right here. And then there's a question with the conclusion, a hypothetical question, but make sure to link cause and effect with that. Thank you. Thank you.